Thank you, Julianne. Welcome to the non-coffee ILR session this afternoon. So this is my normal nap time, and I was looking for some coffee. So
I'm going to find you some.
the lines or the lights are down. So if you want to start your nap now, that's fine. This is my normal nap time. Today we're going to talk about Admiral Rickover and his nuclear navy, and I'm going to give you some information. But he was a well-known man in the Navy, and the worst message you could get was Admiral Rickover is coming to visit. And there was a rig for Rickover Bill. He would always ride the nuclear submarines on their first trip, and he would come and stay on the living barge. And the living barge room where he would sleep had to be light-proof, so you had to go in there and turn off all the lights in that stateroom, turn all the lights on everywhere else, and then put tape over everything where the light leaked in. And he liked to have a barber nearby, and he liked to have seedless grapes. If you couldn't get any, there was a young seaman who was designated to put the seeds out of the grapes that we were going to give him. And there had to be S1w lemon drops handy. And if he came onto the living barge and the person who was there standing by the door would say, "Attention on deck," he would get really angry. So it was an interesting time. He had nicknames sort of like KOG, for the kindly old gentleman. My first submarine commanding officer went down for an interview, and the only time he ever swore was when he talked about Rickover, and he would say, "That's so be," you know. That was the only time he swore. Okay, let's get started here. We have a lot to do, and because then I want to get into sea stories and lies and what have you. Who knows? Oh, there we go. Okay, I want to tell you about Rickover because he was a very interesting, and I think I have it. Yep. Okay. He was born in Russian-occupied Poland. That area of Poland was sometimes Russian, sometimes German, sometimes Polish, sometimes Austro-Hungarian. So he was born at the time Chaim Godalia Rickover in Russian Poland. He immigrated with his family in 1905 to the USA with his mother. The father had come over earlier, and they joined him in Chicago. He went to John Marshall High School, graduated with honors. He went to the Naval Academy. He was 107 out of 540 in the Naval Academy. Now, there's a rumor, you see on the right, some blue arrows pointing to a page where he had his picture on it, and he was very unliked by his classmates. He was probably the only Jew at the academy at the time, and his page has perforations, so if people didn't like it, they could rip it out. But that does not seem to be true, because the one on the left is also him and his discussion there. And it is not on a perforated page, so you could not get rid of all about Rickover with that perforated page if it's really true. He was on the little destroyer there, the Lavalette, and then he was on the battleship Nevada. But look at the destroyer, you see a blue arrow pointing down. There's a little gun on a little ship, and keep thinking about that. In 1930, he got his Master of Science in EE at Columbia. And then later he was qualified in submarines, qualified for submarines. And again, you have a little gun on a little ship on each one of these submarines. And I'll talk about that more later. He translated Das Unterseeboot from German to English in 1933. He was CO of a minesweeper, and I don't see a gun on that one. And it may be because the minesweepers were worried about magnetic mines, and if you had a great big steel gun on your deck up there somewhere, you weren't very anti-magnetic. Okay. In 1937, he was promoted to lieutenant commander and became an engineering duty officer, which meant he was no longer eligible for command of ships at sea and would be assigned to shipyards and the Bureau of Ships and so forth. He was assigned to the Cavite Naval Shipyard in 37, which is in the Philippines. It's a ship repair facility, I think, instead of a naval shipyard. And ships in the Pacific could come to Cavite for mid-level repairs that couldn't be done at sea, but not full overhauls. He became assistant chief of the electrical division in BUENG, the Bureau of Engineering at the time. The names keep changing. It was BUENG, BU ships, nav ships. I don't know what the name is now, but same thing. He reviewed the World War I technical manuals, all of the contracts that he had for electrical stuff, and he rewrote all of them and updated them, and he became a fierce program manager for electrical installations throughout the war on all the Navy ships. And he invented a mechanism that would go in our great big electrical switchgear, which are about as big as I am or bigger. And what would happen was when they fired the big guns on the battleships or when there were mines nearby or explosions, the rattling of the electrical gear would cause the electrical circuit breakers to trip open. And he invented a mechanism that would, if it felt an explosion, there was some kind of a mechanism that would kind of be flipped up and it would prevent the circuit breaker from opening, but then it would drop back down and it would perform its safety function. In 1942, they sent him out to Hawaii after Pearl Harbor to supervise the electrical repairs on the California, which is not doing so well in the photo on the right. In January 42, he was promoted to commander and then temporary captain. And during the war, people got promoted unbelievably rapidly. And so he was a temporary captain. And they assigned him in 45 a ship repair facility, Okinawa, but it was destroyed by a typhoon. And Carol's father was on a troop transport in that same typhoon or another one in the Pacific about that time. He became head of the electrical section of BU Ships. They changed the name from BUENG to BU Ships. In 1945, also, Oak Ridge was assigned the task to develop nuclear electrical plant. So that was all the Oak Ridge engineering activity. And he got himself assigned down there in Oak Ridge in 1946. He wasn't assigned as the officer in charge, but he acted like he was assigned as the officer in charge. So he required the reports from all the classes that everyone was taking, the civilian engineers as well as the naval officers, every week to make a report so everybody could keep up at the same level of their education about nuclear power and a nuclear power plant. In 47, he was back in DC in the Bureau of Ships. And at the same time, Fleet Admiral Nimitz came to Washington to be the chief of naval operations. He was a submariner in the Pacific, and apparently they may have known each other by some kind of paths being crossed. But he was able to convince Nimitz that we needed a nuclear-powered submarine. He shepherded a memo from CNO to SECNAV to AEC to support joint development of nuclear reactors for Navy ships. It didn't say Navy submarines because he wanted the rest of the admirals to come on board with nuclear power, although it was going to be submarines. He approved zirconium, which was a metal for the cladding of the fuel rods. And he was head of both BUSHIP's Nuclear Power Division and the Atomic Energy Commission Division of Naval Reactors Development. So let me just show you this. You see the blue arrows there. They point to his jobs. On the left is Naval Reactors Branch of the Atomic Energy Commission, reporting to Division of Reactor Development, directly down from the AEC General Manager. On the right-hand side, you see the Navy Bureau of Ships. He was Assistant Chief for Ships, he reported to, and under that, he was the Nuclear Power Code 490. And you can see that he had, let me see if the laser is working, he had some direct connection with Electric Boat Shipyard that built a lot of the submarines in World War II. And on the left, he had a direct connection all the way down through the Schenectady operations, Chicago operations, Pittsburgh, Bettis Lab, and we'll go into these things. And so he was double-hatted, and he went by the golden rule. He who has the gold makes the rules. So he controlled AEC and USN dollars. He hired and fired managers, which he probably wasn't allowed to do, for General Electric, for their nuclear people, for Westinghouse, for their nuclear people. He selected General Electric and Westinghouse, and then he put the heat to them to make sure they did what he wanted them to do. He worked the Atomic Energy Commission against the U.S. Navy and the U.S. Navy against the Atomic Energy Commission, and we'll have some more discussion about that later. He personally selected all naval officers that were in his program from the beginning. And by the time he was retired, he had probably interviewed 40,000 officers. And Will was telling me the current director of Naval Reactions has interviewed, 40,000 himself. So they're probably personal interviews of naval officers in the order of 100,000 since the program began. So what does that mean? To be selected for nuclear power, you have a Rickover interview. You have an initial briefing. When I was called up in February of 1964 for my interview, along with my good friend Charlie McVeigh, we were both Burke scholars getting PhDs in nuclear energy at Cornell at the time. We went down, and the first meeting is with the Bureau of Personnel, because they told us, look, if you have a bad interview, don't write your congressman directly. Come and talk to us, and we'll try to smooth it over, because this was a selection process. If Rickover didn't select you, you were back to the fleet, doing whatever you were doing before. So there's 3 to 5 or 6 preliminary interviews. My interviews, one was the director of reactor engineering, and we talked about my dissertation topic. Another guy was a director of chemistry. He had been to Cornell. We talked about changes in Cornell since he was there. Another one was a naval commander who later became my commanding officer. We talked about the officers that were at the Naval Academy when we were both assigned there. And there's probably 1 or 2 others, but for me, it was just chit chat with these guys. For a lot of other people, it was hell on wheels. And then you got the interview. So at that point, you were called over to, in that days, it was the old Navy building downtown Washington on the mall, the old World War I temporary buildings that had been there for a long time. You were introduced to a naval officer who was your guidance. He was actually the witness to what happened when you went to see Rickover. So if you had a big complaint about Rickover, there was a senior naval officer who was there, and he saw the whole thing. So then you'll get invited into Rickover's office. It was an old beat up Navy standard metal desk piled high with papers. and he was sitting off to one side, perpendicular to me. I don't think he ever looked at me. He had a folder there, which may or may not have had anything to do with me. And my entire interview was, "You married Wynn?" "No, sir, that's all." So that was my interview. But he could say that he had interviewed and selected me. And the rumor was that was to protect us from Congress. So if we had screwed up, he could go to Congress and say, "I personally selected that man. Are you questioning my judgment?" That may or may not be true either. One other interview I'll tell you about, and then I have a book here, Down Deep, which Don McLaughlin has read, and every time I pick it up and read, I learn more things. This is about Charlie McVane, the other naval officer I was telling you about. It's excellent reading. Charlie was called in, and he was a surface officer. Burke program scholars were sent to sea for a year to get qualified at sea, and then we could pick our university and go get a PhD in anything technical, physics, or math. And so Charlie had been a surface officer, and his CO had cycled him through everything, so he learned about the Navy. And then when he went in for his interview with Rickover, the whole interview is in the book there, but basically he did not want to come here to be a nuclear engineer. So he told Rickover, he said, I need to go back. I've been 1 year at sea, 4 years in school. If I join your program, I have another 1.5 years of school before I ever get to another ship. I want to go back and do my job as a naval officer. And Rickover was basically shaking his head saying no. And he said, "Well, what are my options?" Rickover said, "None." He said, "Then God damn it, I'm a volunteer." And the other one was when I went to nuclear power school, the land classes, the guy who graduated first by the way, Charlie graduated first in every course he ever took. This guy had graduated first at the Naval Academy. He was an ensign in my class at the school in Mare Island. And he had not gone to the first series of interviews that midshipmen were called down to Washington for their interview with Rickover. And he later decided that he did want to be a nuclear engineer. So he asked permission to go down to Rickover's office and get the interview. And when he got into Rickover's office, Rickover said, "Who the hell do you think you are, just signing up and making an appointment to come down here, and you didn't come on the original time? Get out!" So this ensign left, and he slammed the door and broke the glass in the old man's door. But he was selected. Water, thank you. So, but he was selected. So the interviews were famous throughout the fleet. Then the classroom training, what did we do? 6 months. We studied nuclear fission, fluid dynamics, fuel element theory and design, heat transfer, mathematics, including the differential equations for neutron distribution. That was the only math test I got a 0 on. It said, describe the nuclear flux in a rectangular reactor. So I wrote down the answer. I didn't, because I'd been doing that for 4 years. So I knew what the answer was. It's a cosine function. And so I hadn't read the other little part that said, show all work. And so the guy put a 0 because I didn't show any work. I told him, I didn't do any work. I know the answer. 0. Okay, we studied radiological theory and chemistry. Then we went to a nuclear prototype for 6 months for training. And the first thing you did was go to some more class and learn about that particular prototype. In my case, I went to the D1G, which is a GE-designed destroyer nuclear power plant, which was very well designed. I liked the plant, nice. And then we had to go in the machinery design and operation of every piece of equipment that was in that reactor and engineering spaces. And I just loved it. I enjoyed playing with all the machines and everything, but we had to learn how to open the steam stops and bring steam into the engine room and operate every machinery. And learn how to start up the steam-powered main feed pump, learn how the generators worked, how everything was connected together, and all of that part. Then there's engineering officer of the watch training. In addition to that, all the enlisted guys had to do all that stuff on all the machinery also, particularly the kind of machines they would be operating. So the engineering officer of the watch training, we had to learn how to start up the reactor, bring it up to power, bring steam in the engine room, start all the equipment, and get everything operating. And then there was an oral exam. After the oral exam, you were given a white web belt instead of your khaki belt. And that identified who had been qualified as engineering officer of the watch on that particular reactor. So they could tell whether you were a newbie or a qualified guy. Okay. Then we got ship assignments. So that was a little diversion there. Rickover, controversial, of course. Hyperactive, politically blunt, flamboyant, and he was a workaholic. I think he slept maybe 3 or 4 hours a night. He always demanding of others without regard to their rank or position. I mean, he would have a Navy captain come in to try to be the prospective commanding officer of an aircraft carrier. So this is a fairly senior guy, and he would throw him out of the office too if he didn't like him. Okay. Little tolerance for mediocrity, none for stupidity. Hated the bureaucracy, but he was an expert at manipulating it. And we'll see some of that in the next to last lecture when we talk about civilian power plants. If a person was dumb, Rickover thought he should be dead. Okay, he established the Bettis Atomic Power Lab with Westinghouse near Pittsburgh. None of that existed until he got into Westinghouse. And these Westinghouse and GE were kind of in a slump after the war because they weren't building all of these turbines and steam equipment for ships because they weren't building any ships. So Westinghouse was absolutely delighted to have Rickover come in and beat him over the head because it meant jobs. So, and he made the unilateral decisions on who was going to do what. So he liked the way Westinghouse was working. That meant they were listening to what he told them to do and doing it. He assigned them to design the reactor for the submarine and to build the prototype and the nuclear reactor for Nautilus simultaneously. Now, this is unheard of in nuclear or any kind of other engineering development of any kind of a project in the whole country. You don't build them simultaneously. This is Electric Boat on the right down there, and the diagonal dock is a dry dock and looks like it has a submarine in it. The covered building on the left is a shipbuilding ways. That's where you build ships before you slide them into the ocean. But Electric Boat was tasked with building wooden and cardboard mock-ups of the entire engineering spaces, the reactor, the pumps, the steam equipment, and everything in a 28 to 32 foot diameter steel vessel as it would be on the ship. Electric Boat was selected to build a Nautilus and to do those full-scale mock-ups. But they were going to design the submarine and the land-based prototype reactor at the same time. He went up to Portsmouth Naval Shipyard and talked to them. He wanted to assign them the Seawolf. And they were busy building the post-World War II diesel submarines and said they didn't have time or ability to do that. So Rickover was blunt, as I said. He went into the commanding officer of Portsmouth Naval Shipyard's office, picked up the phone, called up the president of Electric Boat and said, I'll be down there in 3 hours and you're going to build a Seawolf as well. Thank you, goodbye, clunk. And he left. He was sort of brusque. Coffee is here. Anybody wants coffee? 1950, CNO, the Chief of Naval Operations, Bureau of Ships, and the Atomic Energy Commission approved a 1955 launch date for the Nautilus, and they'd never built a reactor before. And Rickover liked that. Give me a date, and I'll just beat the hell out of everybody until they perform the duties required to get there. 52 hafnium is selected for the control rods. Hafnium is an impurity in zirconium ore, and it highly absorbs neutrons. So if you're going to use zirconium for the fuel rod cladding, you have to get the hafnium out of it. And they said, oh, cool, we'll make the control rods out of that. On my 16th birthday, the Nautilus S1w, the shipboard, our submarine first design Westinghouse, S1w, went critical in Arco, Idaho. And that's really incredible. They've got this reactor. Nobody ever built one before. Nobody had built a pressure vessel. Nobody had done any of the stuff, but they took that thing critical in 1953. And only 3 months later, they operated the S1w reactor at 100% power for 100 hours, complete straight through. And that simulated a crossing of the Atlantic by a submarine. So it was a big bragging milestone. Nautilus was commissioned in 54, went to sea 55 to 1980. 54 Shippingport Commercial Power Plant was assigned to Rickover, and we'll talk about that in the civilian reactor course in a couple of weeks. But they assigned it to Rickover basically because they were sure he would make it happen. This is the S1w Prototype in Idaho. It's built in a submarine hull cylinder, the same diameter as would be the Nautilus. So as they started to figure out how to build this reactor, they also had to figure out how to cram it in a very limited space. I have not been to Idaho. You've been to Idaho, haven't you, Will? Somebody back there has. Don, did you go to one of the prototypes? Yeah. Which one, A1W? Was it in a little round tube like that? I remember correctly, yeah. So Don McLaughlin, a nuclear engineer, and then he became Dean of the Arts at the University of Florida. I don't know how that works, but it worked okay for Don and the rest of us. Okay, now this is the Nautilus, and just take a look at that. Electric Boat knew how to build submarines, and everything from this thing we call the sail with the periscopes and masts, everything forward, they had been building those for 15 years or more. So that was no problem. Everything after the sail, this is the reactor compartment, auxiliary spaces, engineering spaces, all of that was all brand new, and nobody had ever done anything like that before. So the Nautilus and the Prototype were authorized, fast-tracked. Building the submarine itself was no problem. Designing and engineering a totally new technology was. One of the questions early on, would there be enough U-235 to make the fuel rods? And what enrichment percentage did it need to be? Remember, we first had, the first demonstration bomb was plutonium, and then they dropped the U-235 bomb over Hiroshima, but they couldn't test it earlier. They didn't have enough U-235 and 45 to waste a test with U-235. The fuel element construction, nobody had ever done anything like that before. You need to put some uranium in a very thin tube clad with zirconium, and you had to run hot water by it. The reactor plant on my submarines was running at an average of 480 degrees in the reactor. So nobody had done that before. So they had to design all of this stuff simultaneously. The pressure vessel design is probably some 9 inches or more stainless steel, and they had to build it and bolt it all together. And they hadn't done that before. The control rod drive mechanisms, very important to shut down the reactor, but they had to be fail-safe up to 45 degrees because submarines will run around the ocean and do angles and dangles, and if you make a hard left turn, the ship will rotate a little. And when we went out with midshipmen in the submarine in the summertime, we like to do angles and dangles, so we'd be at about 300 or 400 feet, going ahead full, put all the dive control surfaces in full dive and make a really steep dive down to test depth and bop back up. And lucky for me, we always bopped back up. New materials refinement. They had to figure out how to find it, get the ore separated, make the metal cladding that they need, weld it together. It was amazing. They had to design a steam generator. They're going to pump this 480-degree water through some U-tubes in a steam generator that had never been designed before. The primary coolant pumps and valves. There was a requirement by Rickover that there could be no leakage. And the manufacturers of the pumps would come back and say, well, how many drops per minute is that? No leakage. It was like a George H.W. Bush moment. Read my lips, no leakage. And that included all of the piping that was bolted together to take this very high pressure, high temperature water in and out of a steam generator and make steam. So the steam plant was in a confined atmosphere of a submarine. I don't know if you've ever been in a steam plant, but if you ever walk around anywhere where there's steam, you'll see a little wisp of steam coming out. You can't have that in the submarine. No leakage. Extremely limited underway maintenance requirements. The reactor compartment was basically sealed and shut when we went to sea, and you couldn't go in there unless you shut the reactor down and let it cool down. And very few times anyone ever did that underway. Safety and reliability of paramount concern. And we'll talk about that more next week when we, somewhere along the way, when we talk about nuclear disasters. The United States Navy nuclear power program has had 0